let's look at two specific triangles, our isosceles triangle and our equilateral triangle. We're going to look first at our isosceles triangle and then the equilateral one. So this first page, parts of an isosceles triangle. Remember, isosceles means, which triangle is that? We got two congruent sides and two congruent angles. So our two congruent sides, we're going to call those our legs. So let's look at this triangle we got over here. We got an isosceles triangle, A, B, C, and we have these little tick marks. Remember, that means that they're congruent. So these are our two congruent sides, and they are called our legs. The angle where the legs intersect is called, so this angle right here where the two legs meet, it's called the vertex angle. Vertex angle. The side opposite the vertex, so the one opposite, so opposite the vertex, this is called our base. Base. The angles along the base are called, very cleverly, base angles. Angles. So this angle and this angle, those are our base angles. And so something to note here are two congruent sides. So our legs are the ones that are congruent. Our base angles are the ones that are congruent. All right, so our theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So what does that mean? So our legs up here on this triangle, they're congruent, right? So the angles opposite those are congruent. Or if you label them our base angles, they're our base angles. So the opposite is true, that if two angles are congruent, then the sides opposite, so it works both ways, those angles are congruent. So if you're just given these two angles and they're the same, then the legs are opposite of them and those two are congruent. Let's look at a few isosceles examples. Find the measures. We want to know the measure of angle J and angle K. So what did our converse isosceles triangle theorem say? If two, oh no, wrong one, sorry. Isosceles triangle theorem. If the two sides are congruent, these two sides are congruent, then the angles opposite of those sides are also congruent. So that means that 6J is also 68. 68 degrees. And so then what is K? What's this vertex angle? Well, we can take 180 minus 68 minus 68, and that will give us K. That will give us 44 degrees. So the same is true here. So this is if the two angles are congruent, then the sides opposite of them are congruent. So that means that these two legs are legs and they are congruent. So y to z equals 12 centimeters. Again, our vertex angle, we're going to take 180 minus 77 minus 77, and that gives us 26 degrees to give us the measure of angle y. So the same is true. We can do all of this with our variables. So if our sides are congruent, then the angles opposite of them are congruent. So what does that mean? That means that 5x plus 9 equals 8x minus 30 because those two angles are congruent. So I do my math, solve for x equals 13. I'm kind of abbreviating these notes to go through them a little bit quicker. If you are struggling with solving for x, then you need to let me know, and we need to do some stuff about that. So this last one, we're still finding the variable. It is the converse theorem. These two angles are congruent, so the legs are opposite of those are also equal. So 15x plus 7 equals 23x minus 17. Do the math. X equals 3. All right, like I said, let me know if you're having trouble going through that, solving for x. Moving on to our equilateral triangle. Remember our equilateral triangle. It's equilateral if and only if it is equiangular. That is a tough word for me today. So what does that mean? That means that all the sides are the same and all of the angles are the same. So if angle A, B, and C are all the same, then that means that the side AB equals BC equals CA. And the opposite is true. That if all of those legs are the same, then angle A is the same as angle B, is the same as angle C. And guess what? We already know what our angle measures are because we know that the total of this triangle is 180. So if I divide 180, since they all have to be the same exact amount, 180 divided by 3 is 60 degrees. So each of these angles is 60 degrees, always in an equilateral triangle. It will never be different. So here, find the measures. We want to know what the measure of angle C is. We're in an equilateral triangle. We know that because the other two angles are 60, so C has to be 60. Since all of the angles are congruent, that means that all of the sides are congruent. So each of these sides are also 9 feet. The second one, JKL, we know it's equilateral because each side is congruent. We know that by these little tick marks. So each side is 24, 24. If all the sides are 24, all our angles are also the same, and they are also all 60 degrees, 60 degrees, 60 degrees. These are easy peasy ones. Find the variable. We know we got an equilateral triangle because of the tick marks here. So that means that each of these angles are the same. And what are each of these angles? They are 60 degrees. So we know that this equation is going to equal 60 degrees. It has to. So solve for x. 4x plus 8 equals 16 degrees. X equals 13. And finally, this last example. We know we got an equilateral triangle because these two angles are 60 degrees. Try it on your own. Let me know if you have questions.